Sure you have a book and your toolkit out there, okay? Book and your toolkit. All right, first things first, we're going to talk about the definition of a kite. Now, if you had to draw a typical kite that you'd sort of go outside and fly, what would it look like? Yes. It kind of looked like a diamond, right? So it would draw something like this, right? There's that one. And there's that one. So do we agree that it would look something like that? Yeah, okay. All right, so we're going to try and come up with the definition here. What do you notice about this particular figure that we have, John? Can you say anything about it? Yeah. Two pairs of congruent sides. So you mean something like this, right? So that side and that side are congruent. We agree with that part? And this side are congruent, right? But not all four are congruent, correct? Yeah. All right, good. So for us then, our definition is going to be, well, first of all, how many sides does this thing have? 4. So that automatically makes it what type of a polygon? Quadrilateral. So we have a quadrilateral. What's that? No. This is just definition, yeah. It's a quadrilateral that has 2 pair of consecutive congruent sides. So what they mean by that is, this side and this side are consecutive and congruent, but it's not the same, and this side and this side are also congruent, but there's something else that we have to add to that, right? But opposite sides are not. So what they mean by that is something like this. If I take a look at this side here, what's the side that's opposite to that side? This top left one, right? So these are not congruent. Okay, so there's our definition of a kite. It's a quadrilateral that has 2 pair of consecutive congruent sides, but opposite sides are not. So what's the difference between this and a rhombus? Yeah, Allie. Rhombus has 4 congruent sides? Yeah, she says a rhombus has 4 congruent sides. Is that correct? Yes. That's correct. Okay, great. There we go. Second part of the day. Let's add theorems 6.18 and 6.19 into our toolkit. All right. I've got 2 examples for you, and we're going to use the Pythagorean theorem. And the Pythagorean theorem has to do with what? Who remembers? What type of triangles? Chad, yes. Yeah, it's the right triangle. We're going to use that. So draw yourself a kite for this example. And let's call the kite A, B, C, and D. Okay. Also, draw in the diagonals of the kite. So let's draw B to D, and let's draw A to C. All right, I'm going to give you the lengths of some of these diagonals here. I'm going to tell you that where they meet right here, let's call that M. So if I tell you that AM is equal to 5 units, and CM is equal to 5 units, BM is going to be 4 units, and DM is going to be 7 units. The question I have for you is, what is segment AB? So what is this segment over here, and how can we figure it out? Yeah, we're going to use the Pythagorean theorem. So who sees it? Who sees, how can we use theorem 6.18 to use this? Eugene, what do you got? Okay, if these are diagonals, what do they meet at? What does theorem 6.18 say? Where do they meet at? They intersect at what? Yeah, which is 90 degrees, right? So if this is 90 degrees, do you have a right triangle right here? Yeah, so think about this, right? Think about this right triangle that I'm drawing right here. And what part are we looking for? The hypotenuse, right? AB. So here's what we can say, right? This has to equal the square root of this side length squared, which is 5 squared, plus 4 squared. So AB has to be the square root of, let's see here, 25 plus 16. So AB must be the square root of, what's 25 and 16 added together? 41. All right, let's keep going with this. If I know that AB is the square root of 41, what else do I know automatically? BC is also the square root of 41. And why is that the case? Rocio, why is that the case? Because what is this figure? This is a figure of a what? No, not a triangle. The whole figure, ABCD. ABCD is a kite. So what do we know about kites? What's it say up here? Consecutive congruent sides, right? So that means that BC also has to be the square root of 41. All right, everybody, please. Okay, Chad, you got it? Yeah. Oh, I meant Jared. Sorry, Jared. You said you had it. What'd you come up with? Can you tell me how you got that?
So if you take 5 squared and 7 squared and you add them together, when you take the square root of 5, or when you square 5 is 25, and when you square 7 is 49.
Mm-hmm.
And you add them together, you get 74.
Square root of 74. Do we agree? Is he right or wrong? Is that correct? All right, if CD is the square root of 74, then what is AD? AD is also the square root of 74. That's a 4. So those are congruent. Those sides are congruent. Are you feeling pretty good about that one? We can figure out all 4 sides of the kite. Okay. Next example, also draw yourself a big kite, but draw it sideways. So ABCD is a kite. That tells us that in the problem. Thank you very much. If I tell you that this is 120 degrees, if angle A is 120 degrees and angle C is 50 degrees, I need us to figure out the measure of angle B and the measure of, right? Because we know exactly one pair has to be congruent with each other. So we're going to do exactly what you said. We're going to add 120 and 50 together, and that gives us 170, right? We're going to take 360 degrees because that's how much there is total. We're going to subtract off 170. Isn't it 190? Yeah. 190 degrees. Now, we know 190 degrees has to be both the combined angles, so therefore we're going to divide that by 2 and get what? 95 degrees. So that means that both of these, this one's 95 degrees and that one's 95 degrees, because we know that in a kite we have exactly one pair of opposite angles that are congruent, and it's obviously not these two because they aren't the same. You with me on that? All right. Any questions on the last box? Okay, here you go. The last one I want you to think on your own. Okay. I'd like you to answer